Hi, everybody. Welcome to our session. This app is brought to you by MVVM, a Hulu case study. My name is Matthias Shapiro. I'm a Windows Phone Technical Evangelist with Microsoft.
And my name is Zachary Pinter. I'm a mobile developer at Hulu.
So we're going to talk about a little bit about MVVM, what it is, how you can use it inside of your applications. I'm going to cover that, and then Zachary is going to talk in depth about how Hulu's used MVVM to drive a multiple device platform strategy. So let's move ahead. Also, stick around. At the end, we have a Nokia 925. We pay particularly close attention to the slides. We'll ask a trivia question. Whoever gets it right first will get a new Nokia 925. So back in the old days, there was the way of the win form. And with the win form, we had our code behind, and when we started up our application, our code behind would go, and it would grab some data. And if we wanted to show any of that data on our UI, we would have to grab every UI control and say, update this, update this, update this, update this. All those UI updates would go to our UI and controls, and then anytime we interacted with those controls, we had to make an explicit interaction call back to our code behind. We'd handle that in the event handler, and the great circle of WinForm life continued. And this was a fine way of doing things for the time, but it's a little bit old-fashioned. It's kind of like running a telegraph, where there is this magical machine that handles just one piece of this. But in order to communicate, what we really want to do is communicate from one person to another. And the telegraph puts a lot of manpower in between that gets in the way of that effective communication. So instead of thinking of the ways of the WinForm, we're going to talk about the ways of the Windows Phone, where we use C# and XAML and using MVVM. Instead of us building up all of that structure for effective communication between our business logic and our views, our UI, it's more like a sort of, dang it, I'm losing my brain already, telepathy sort of thing, where all of the communication happens instantaneously without us thinking, without us managing it, and without any of the side effects that you normally associate with telepathy. So that doesn't happen. So if you're new to MVVM, what is MVVM? Well, it stands for Model, View, View Model. And it looks like I've introduced those out of order, but they're in that order for a reason that we'll see in a moment. But why would we want to use MVVM? Well, it gives us a couple of great things. The first thing it gives us is this really great design development separation. Using MVVM, we can work inside of our UI, inside of a design scope, and we can do all of that work without having to worry about, okay, what's happening inside of our view model, what's happening inside of the code, inside of the business logic. We can just say, I want to show this piece of information, and move ahead from there. MVVM gives us the possibility of a great deal of code reuse, so that a lot of our view models can move from one project to another or from one view to another. And the models also, we can see a lot of code reuse there. One of my favorite things about MVVM is that we can actually drive multiple views on the same logic. We'll see this in the demo that I have, and a lot more in the Hulu demo. But this means, as a way of example, if I wanted to drive multiple views, let's say I have a patient information software, and I have a doctor who wants to see one thing and a nurse who wants to see something else, but I don't want to build the structure to pull that information in and do the business logic. I don't want to do that multiple times. Well, with MVVM, we can build a view for the doctor, a view for the nurse, and have the same view model driving both of those views. Then lastly, MVVM gives us the possibility of view logic testability. Because we have that great design development separation, we can emulate what's happening inside of our UI by calling things like commands and updating data bindings. We'll see that in just a moment. So an overview of the specifics of MVVM. Let's start with our model. Our model is a simple representation of data. In many cases, a model is exactly the entity that you might store in your database. It has no logic or functionality, or very minimal logic or functionality. Sometimes I'll have my model create an additional property, and I'll have some logic that takes the property I pull out of my service or database and maybe turn it into a different type. But very, very minimal logic inside of our models. The bulk of our business logic, the bulk of our application logic is going to happen inside of our view model. This is where we're going to create our services, make our service calls, do our data management, things like storage, that kind of stuff. And the view model kind of relates to the model in that the view model is going to hold objects lists of models or sets of models. And so those models are going to live in a more concrete manner inside of our view models. And then lastly, we have our view. Now, think of the view as anything that the user sees or interacts with. So the view is going to be all of our controls, all of our buttons. Any interaction is going to happen on the view. We're going to navigate to the view. We never navigate to a view model when we open up our application. All of our interaction layer is going to be living there. Our view communicates with our view model in two very important ways. The first one is using data bindings. The view can communicate to the view model, and the view model can communicate to the view. And then we have commands. Let's dig into those for just a moment. With data binding, the normal way, there are a couple different ways of doing data bindings, or there are a couple different things that happen. The big one is the view model communicates to the view. The view model takes some data, and using this iNotifyPropertyChanged interface, every time a notified property is changed, it sends an event handler and sends a signal, and anything that's listening using this binding that you see in our view XAML is going to automatically update in the UI based on those changes that we see. So that's really cool, but the thing that I think is really exciting is that data bindings aren't just from the view model to the view. They also go from the view to the view model. We can set our data bindings so that they're two-way. And that way, if we have a text box and we want the information that we're typing into that text box to update instantly to our view model, we can do that simply by setting the data binding to two-way. So with commands, commands are a way of translating interaction on the view level into some sort of code or command, some sort of code or some sort of function in the view model. I'm sorry, I think I got that wrong. It's an interaction in the view to function in the view model. Baked into Windows Phone is the iCommand interface. And so we can create commands using the iCommand interface, and it will have these great can execute change properties that can actually turn buttons on and off when a command is not able to be executed. A couple of implementations of this that make commanding a little bit easier are a delegate command, relay command. I encourage you to go bing those at your leisure. And they're really some really great implementations. And what they basically do is they make it so we don't have to constantly be creating new classes for every single command. We can create a property inside of our view model and put functions inside of there. And, from the view perspective, it's still that very simple binding. Command equals binding my command. And there's ways to bind to a view control if we don't have the command option, but we'll look at that in the demo. So when we're building with MVVM, one of the things we're probably looking for is code reuse. And so we want as portable an MVVM structure as possible. And so this is the structure that I'm going to be talking about. The idea that we have portable class libraries that hold as much of the code as we can easily manage in between different projects or perhaps even in between different platforms. And then our Windows Phone project that handles all of the rest of it, everything we can't put in our portable class libraries. Our portable class libraries are going to hold things like our service calls out to get data and pull it back in. View models, I say have limited or abstract here because there are maybe some things that our view models that we want to do inside of our view models that we can't effectively do inside of a portable class library. But then again, our models, we talked about that, just those dumb models. Portable class library is a perfect place for that. Inside of our project, we could have models that either are extensions of our portable class library models, so build upon those, or implementations of those abstract view models. And they can do things that the portable class library can't access. They also, inside of the project, we're going to want to keep all of our views. Anything related to application lifecycle and navigation is going to live inside of our phone project. And so I come from a world of usability, and in usability, we try to learn things through forced metaphors. So how to be a great designer by getting to know your hot dog cart vendor. So we're going to learn about MVVM through forced metaphors. Imagine the Windows Phone blog is our view model. There's lots of logic in there. It can do a lot of things. It can manage a lot of stuff. And some of the things that it manages are these model concepts, a blog post, a comment. These don't do anything on their own, but they can interact together because of the logic that we have inside of our Windows Phone blog. But I'm not watching the Windows Phone blog all the time. I don't see whenever something updates because I'm always watching Twitter. So in this forced metaphor, Twitter is our view. Windows Phone blog is our view model. How do we make sure that everything that happens on Windows Phone blog gets instantly updated to Twitter? Well, we use Ginny Cahey. Ginny Binding Cahey watches the Windows Phone blog constantly, and whenever there's a new blog post, when something changes, she implements her iNotify property changed interface. She takes it, she puts it on Twitter, and now I can see it, and I can interact with it, I can click on the link, and I can maybe go create another comment in the Windows Phone blog. So you've seen a lot of diagrams, and you've seen a lot of boxes, but you probably have this idea in your head of, okay, I think I know what this is, but I haven't really seen it in reality. It's still kind of a mess of something that I feel like there's a representation out in the real world. And in short, you know that this means something. I got one laugh. That was okay. This is, anybody, Close Encounters of the Third Kind, one of my favorite movies. But we're going to take this mush of abstract architecture and turn it into something that's a little bit more real. And so what you see over here, these are the Philips Hue bulbs off to my left here. Philips Hue bulbs are this really cool project where you can take this. Wow, everything is just kind of closing on me instantly. There's this Wi-Fi bridge, and it can communicate to these bulbs, and it sends back a RESTful interface that I can interact with on my phone. So if you want to follow along, you can go to huemvvm.codeplex.com. I've got all the code for this, and you can look at it and take a look at what my MVVM structure looks like. We're just going to switch over to my phone here. And you can see what we have here is I have 3 different UIs that manage my 3 different lights. And the sliders that I have here, these are bound two-way to my view model. So every time I change a slider, there's no code behind here. It's just bound to that view model. And so every time I make a change with my slider, it updates the light appropriately. And all of this is happening inside, the very large majority of this is happening inside of my portable class library. But this is the bindings to the sliders are happening via a two-way binding. The commands are happening using some behaviors that we're going to talk about when we dig into the code. And even the little icon that you see behind there, that's not being driven by any sort of logic that lives inside the view. It's being driven with a binding. And so as we dig in, I hope that this concrete example kind of takes that mushy idea of what MVVM and turns it into something that's a little bit more concrete. Can you hear that? All right. Hooray for jokes. Okay. So just as a reminder, this is our portable MVVM structure, and let's dig into what that means from the context of this particular demo. First, we start out with our portable class libraries. Everybody knows what portable class library is. Hopefully, everybody knows what portable class library is. If you go into Visual Studio, you can start a new portable class library template, and it will show you this here. It is great because it means that we can write code that works across platforms. It lives in one source. It's in one project. It compiles into one binary, but it'll hit multiple platforms. And so you can choose which platforms you want to hit using this very handy interface. And it's a really great way of sharing code, especially if you're looking to share code cross-device. One thing I do want to call out is the HTTP PCL library. With Windows 8 and Windows Phone, you actually have different HTTP client implementations, and this bridges that gap. So go, and if you start your portable class library, first thing you do is go into NuGet and install the HTTP client PCL library. Save yourself an enormous amount of pain. So our portable class library model, our Hue light is a representation of the light that we have over here. And when I create my Hue light model, one of the things I do is I implement iNotify property changed. And I know you're saying, I thought you said iNotify property change was for view models. Well, yes, it is, but it's for anything that we want to update constantly. And so we don't want to have to update a new Hue light every time we change a property in it. And so what we do is we say that my Hue light implements the iNotify property changed interface. And then when I create a property like red, I can just implement my notify property changed inside of my setter, and every time it updates on the hue, it updates in my interface, it will update inside of my view model as well. And then to have that, that update reflected inside of my application, I have a very simple XAML binding. Slider value equals my hue light dot the property red. There are going to be some limits to portable class libraries. I have no file I/O access, so I don't have any storage access. I can't perform specific OS functions, things like message boxes or alerts. And in this case, the one I'm really missing is I have no dispatcher timer. And so the animation that you saw there and hopefully heard, that's running off a timer so we know when we're going to be updating the different lights. And so since I don't have that, I need some parts of my view model to live outside of my portable class library where I will have access to these things. And so this is a very simple representation of my view model. I've got bindable properties, hue light 1, 2, 3. I've got a command for updating each one of them. Now, if you want to dig a little deeper, commands can actually take in parameters. So I could have done this with a single update light command and just told it which light to update. But I've separated out 3 of them in order to kind of just make it a simpler concept. And then I have my Hue service instance. And that's all the HTTP calls that go and communicate to the lights. All of that lives inside my client view model. So when I want to take this application, move it into another platform, I can take all of this stuff and move it instantly over there just using my portable class library. But I can actually even share other things across both platforms. I've got my get lights command, and that one is running on a timer so that if I have multiple devices connected to my lights and I update a light on one device, that update will show up on the other device. So I have it running on a timer. Every second it goes and it gets it queries the lights and sees where they are so it can update the UI appropriately. And any sort of storage service, in this case, you didn't see it, but I have to register as a user in order to make sure that I'm authorized to use the lights. And so I store that information in the storage. And everything above the red line here lives in my PCL library. Everything below the red line lives in a view model that inherits from my portable class library, so it gets all the stuff above the line. But then I can share that as link if I need to move in between different platforms. And so now we've talked about our view model, and the real question is, one big question is, where do we put the view model inside the project? Basically, oh, view model, where art thou? And so I like to think of George Clooney here as the attractive person that everyone likes to look at. He's the view, and the dumb guy in the back is the model, and the big guy who does all the work, he's the view model, and the chains represent the bindings. You know, really this metaphor is falling apart, so we're just going to move ahead. There are two places to put your view model. One is you can put it in your app.xaml.cs as a singleton, and the second one is you can create it in your app.xaml as a resource. And so here's the singleton pattern in slide form. What we basically do is inside of our app.xaml.cs, we have a public-private singleton model. If it doesn't exist, we create it, and then inside of our XAML.cs, we have this one line of code inside the initialization, or the instantiation. It says this.dataContext equals app.hueClientVM, and now the data context for our view is set appropriately. The other way is the resource pattern, where we set the XML namespace to be the namespace for our view model, and inside of our app.xaml, we can create an instance of our hueClientVM. And I'm going to switch over to the code so you can see kind of what that looks like and a little bit of what we get when we do that. So I've actually implemented it both ways in this application. We have our singleton pattern here. I like to put it at the top of my app.xaml.cs so that I can just go to my app.xaml.cs and look at all the view models I have available. And then here inside of my resources, I have my client view model. Now, it's up to you which structure you want to use. My preference is to use the resource way, and the reason is because then I can go into Blend, and I can go to my data context here, and I can simply select my hueClientVM out of a local resource. And so for me, that's really valuable, because once I do that, I can go to any of my controls. Let's say I want to change the foreground. I could have the foreground of my application be the same color as my red light by simply going to create a data binding. And because we created the data binding in the resources, we can see here's all of the things that are available to me inside my client view model right here, if you've got a designer, this is really great because they can just say, oh, okay, I want it to connect to the hue light. I want to use a particular converter. Boom, I'm done. The data binding is created, and my foreground is gone because I have no data in there. So back to the view, a little bit more about data binding. With the slider, it updates automatically every time we change the value, either in the view model or in the UI, and those values will update automatically using this binding hue light property, mode equals two-way. But there's more we can do with bindings than simply making a one-to-one relationship. We can use converters. And so the icon that you saw in the back, it was, I can't bind it to the red and the green and the blue. So what I do instead is I bind it to my hue light. And I use, as you saw in Blend, I use this converter called hue to color converter. I'm going to switch to my code again and show you what that converter looks like. So here's my hue light to color implements iValue converter. And what it does is it creates a solid color brush, because that's what our icon is going to be. That's the color that our icon is drawing from. It's drawing from an object of solid color brush. And I create a fallback in case something goes horribly wrong. And then I grab my hue light that I've bound to. And all I have to do is I say, my solid color brush, set the color to the color from my hue light, the red, the green, the blue, and return that. And now I don't have to write any code behind. I don't have anything inside of my view.xaml.cs. I'm working strictly with the binding, strictly with the converter. And so lastly, the thing that pulls this all together is the commands. A slider has a command. I actually was originally going to have the command every time the value changed, but the problem was that if you have shaky hands, the value's changing constantly, and making those calls is a little bit cumbersome on the system to do every 0.05 seconds. And so instead, what I use is this event to command. And this is a behavior, and you can literally just drag and drop it inside of Blend. But it allows you to say, I want to specify the event that runs this trigger. And so in this instance, on the left mouse button up, so when I stop changing my slider, it runs the command update light 1, and my light updates in a nice, clean manner that requires no code behind. And so in terms of the MVVM structure, all of my view stuff lives kind of up here at the top. It all lives inside my Windows Phone project. My XAML lives there, my controls live there, and my data bindings and commands that really tie my view together with my view model are all up there. But if we decide we want to move from a single project, a Windows Phone project, to perhaps a Windows Phone and Windows 8 project, this is how that changes. We're looking at different XAML, we're looking at different controls, but we get to keep using those same data bindings. We get to use those same commands for key interactions. And the code that we write into our converters can work across both platforms.
All right. With that said, I'm going to kick off. Thank you, Matthias. To start with, I'd like to show a quick video of side-by-side here for our two apps. Where do we go?
Do we have is the sound off on this one? Okay.
And the video, oh, it was on the slides too.
We'll
see.
Either or.
Let's see here.
If you want, you can just switch over. I've got it queued up.
Okay. Perfect. All right, so here's a side-by-side presentation of both our Windows 8 application and our Windows Phone 8 application. And the neat thing to see here is that we have a lot of similarity between the two apps. There's the same sort of information being displayed, the same rough architecture of the information where you've got collections of videos, different sets, different pages as you go. But on each platform, we have different XAML that gives a view that really fits well with that particular platform. So this pattern of MVVM, which we've used to great success, lets us have custom UI per platform with shared logic behind the scenes. So let's go through how we make use of that. One of the big things we strived for when we were building the Windows 8 and Windows Phone 8 application is to put as much code as possible into the portable class library. The portable class library really does make it easy to manage your files, to add, remove them, refactor them, rename them, and so on. So while there are other approaches like linking files, and we do use those in a small amount in a few places, it really saves us a lot of hassle if we can just put as much as possible in the portable class library. That said, there are some cases where we'll do a view model in the portable class library, but we'll also have platform-specific subclasses of those view models in each project specific to the platform, and we'll show that off in a little bit. And then finally, I just want to say that the XAML templates that we use, in theory, we might be able to find a way to share them, but XAML is quick enough and platform-specific enough, and we have different views on each platform that we really don't push hard on trying to share those. We might copy and paste an example here or there between the two applications, but largely we have non-shared XAML between the apps, and that works just fine for us. All right, so let's take a quick look at how we structure our application. And you'll notice at the top here, there's an overall application view model. On Windows 8, we have a desktop subclass of the application view model. On Windows Phone 8, we have a phone app VM subclass. And this is a singleton for us. It's around, and it's created right at the beginning of each app instance. And that is really a point of cohesion for the applications where we can share a lot of code. And then additionally, throughout the application, we have all sorts of pages, things like a home page, a movies page, a TV page. And those are all in page view models. And then our most common page view model, the section page, has sections inside of it, which are collections of videos, which are represented by tile view models. Now, to go into this, as I mentioned, there's phone app VM and desktop app VM. And where that's helpful is, if you take a look at this code here, we've stubbed out a lot of abstract methods in our app view model that are just handy helper methods that conceptually are things we want to do on both platforms, but in practice, there's either different namespaces or different APIs for how to accomplish them. So you'll see things like run on the UI, where we want to just pass in a Lambda and have that block run on the UI thread. There's a different way to do that per platform, but by stubbing it out here, we can abstract that so all of our view models can make use of that functionality without depending on any platform-specific APIs. Another good example here is the show message stubbed out method. So each application obviously has radically different views and APIs for how to display a message dialog, but the concept is pretty similar, right? There's all sorts of areas in your business logic where you want to say, okay, this happened, so show the user an okay cancel prompt, or show the user a confirmation dialog. And we can use this show message stub to accomplish that without relying on anything platform specific. You also see some other stuff here like showing a toast or launching a URL in a browser. That's a very helpful thing for us when we want to go to something like a support page or things like that. And we've also gone through some work to abstract the whole concept of navigation for our application. That would likely be something specific for any application, but for us, it's really handy to be able to express what are pages that we might need to navigate to as a conceptual level in our view models, and then handle the details per platform. So let's take a look at our page view model. First of all, this is just, it's almost an abstract class, although technically not. It's the common view model class that every single page is bound to, and we subclass it as needed for each specific type of page. It contains, in the default one, it contains just a few small helper methods and bindable properties, so every page in our application needs something like a title. We can also put in some logic here for things like an app bar. So if we want to express an app bar that's only on a specific page, we can do that in our view models, and then the details of whether it's a top app bar, bottom app bar, how it's handled on phone, how it's handled on desktop can all be handled in the views for those projects. Now, the most interesting page that we have is probably the section page VM. This is pretty much every page in our application, unless you're looking at something like a login page or a help page. It's going to be a section page VM. And the concept here is that you have a page with collections of videos that in both platforms ends up being horizontally scrollable. So section page view models have a list of section view models which represent all the named collections that you see on that page. And you can see here the section view models represent all of these things, where you have something like a list of popular videos. That would be a section VM with the title of popular. Or you have a some sort of editorial section where you've got things like 2013 summer premieres. Again, a collection of videos inside a page that has a collection of sections. So this is what that view model looks like. Obviously, I've left out a lot of details here, but you can see conceptually not very difficult. We have a list of section view models. We have a load method, and that kicks off an asynchronous task that loads all of the sections and initializes them as needed. The section VM itself has several helpful properties for us, and this actually, I think, demonstrates a really nice thing with the view model pattern, is that not every property that you put on your view model is something that you would necessarily want every single view to use. You can just think of your view models as a sort of grab bag of every single Lego brick or helpful property that you might want to have for any particular view that might come up. So here we have a few different things. We have items, incremental items, and incremental items by 2. So if you look, I'm going to go back a slide real quick. If you look at the Windows 8 application, our sections here are not infinitely scrollable. They only have, in this case with the McRubber thing, you see there's only 3 videos there that are being displayed. We don't want to keep loading that infinitely. We want a very fixed number of tiles for that section. So in the case of in the case of iList items, that's going to be a list of 3 items for the Windows 8 view. But in the case of Windows Phone 8, we actually have the ability to keep vertically scrolling this list as much as we want. So in that case, we return an incremental items, or we bind to an incremental items, which has the ability to continuously load more as you scroll. So it's 2 different platforms, conceptually similar properties, but one platform uses the one that returns a fixed number of items. The other platform uses the collection that returns an infinitely scrollable list of items. You'll also notice we have one other helper method here that's really nice. It's incremental items by 2. So on our Windows Phone 8 application, we have poster section, which will do side-by-side movie posters as you scroll. And here it's helpful for us to re-represent that same data source of tile VMs, but instead of giving you the collection infinitely scrollable 1 item at a time, it returns a tuple of 2 items at a time. And here's what that code looks like. So you can see here we have our Hulu collection of incremental items, or just a regular list of items. We also have some neat properties here, like is wider than screen. Now that's a property that Windows 8 doesn't care about, but Windows Phone 8 cares about it a lot. So on Windows Phone 8, we'll use a panorama control, and we'll have some of those sections that can actually be wider than the width of the phone itself. So that property is there and available to be bound to and used as needed, but it doesn't necessarily mean that every single view has to use that property. Additionally, we make good use of having our view models specify which sort of XAML template might be used to represent them. And so here you can see that we have a template name, which is just the standard template that you're going to use for that view, but we also have a template named snapped, which is the XAML template that we want to use when that particular Windows 8 view is in the snapped view on the left-hand side. So same view model, but it's represented in 3 different ways: on the phone, on the desktop, and also in the snapped mode on the desktop. Now, what's inside the sections are what we call tile VMs. And the concept here is that basically every little clickable thumbnail that you have in the application is represented by a tile VM, and there's several subclasses for each type of tile VM. You can see here we have video tile VMs, which are just things like a particular episode of a show. Navigation tile VMs, which are the clickable links. So if you have a button that says TV and that takes you to a TV page, that's represented with a nav tile VM. And we also have show tile VMs, which represent the various shows that you might want to go to. So what that looks like in practice is that we have, here you can see the video tile VM, and same view model for the tile VM, but represented in 2 different ways per platform. Similarly, we have our navigation tile VM, and here it's kind of interesting. You can see on Windows 8 we have a picture to represent that, and it's a clickable thumbnail, but it's almost not even a tile when you get to Windows Phone 8. Here we want a list of text items. We still call it a tile, but it was really easy for us to just put in a different XAML template for how that item is rendered and not care about the images. We just say, okay, whatever the title is, and do a converter parameter to convert its name to lowercase so it looks nice on Windows Phone 8. And then finally, we have our show tile VM. And one neat thing here is that all of our tile VMs have standard properties like title, subtitle, description, but just because those properties are there doesn't mean we need to use them. So on Windows 8, it makes a lot of sense for us to have those big, bold images of what the show looks like. But on Windows Phone 8, we actually have some extra horizontal space here. So we include the title and the description of the show in addition to the image. So you can pick and choose, based on your views, what properties you want to care about. Here's what that base tile VM looks like. It's got things like, again, I said the title, subtitle, description. We also try to abstract our logic for sharing inside our view models. So a helpful pattern we found here is to just let the various view models say what they would be shared as. So we say what the share title is, what the share description is, what the URL that would be linked to for this tile is. And then each platform, we can just look up, okay, they clicked on this view, it's bound to this tile VM, so I'm going to call the share API and provide all of the share properties off of this tile VM to the platform-specific API. Again, very helpful pattern. And we also have stuff like is selectable. So if you notice on Windows 8, you can check mark items. That's really handy for us for things like video tiles and show tiles, but a navigation tile, it doesn't really make much sense to check mark it. So we have a bindable property here that says whether or not it's selectable. So let's go in a little bit more detail of how this tile VM is implemented, or how it would be subclassed. We have our show tile VM, which implements some of these properties, and also says what happens when it's clicked. So here you can see that I'm constructing a show tile VM, and the first thing I pass into it is the show object. So in this case, and going back to what Matthias was talking about, our show is the model class, and it's just a fairly lightweight C# object with a lot of properties, and it's used to store all the data that we have about the show. And then we pass that into the constructor of our view model, which then provides all the helper methods and implements the properties that we need. So you can see here we have things like the title, which returns the show name. But if it were a navigation tile or a video tile, there might be a different property on our model that we want to represent what the title of that tile is. One small thing to point out here, you'll notice that not every one of these have the iProperty change notification built into them. Part of that is just for brevity, but it's also interesting to see that the property change notification is just letting you know when something changes. Your views can bind to pretty much any property that's public off of your view models. They don't have to always dispatch the property change notification to work. And in fact, you can see that our show is being passed in the constructor, and there's nothing about it that's lazy loaded, so we don't have to do a property change notification here. We don't have to add that extra code in, because as long as the data that we're returning never changes, we don't need to send the event. You'll see here with the subtitle, it's just a little bit more examples of how you might want to format things or add some extra logic in your view models. every one of our shows has a genre and the company that it's associated with. So genre would be something like comedy, and company would be something like ABC, NBC, that sort of thing. And if for some reason we don't have both of those properties, then we want to return one or the other. If we have both of them, then return them both with some sort of separator in between. Then it comes to the point of where we need to actually handle what happens when this tile is clicked. So we have a bindable, we call just a bindable action, and that hooks into the command pattern that Matthias was talking about. And here we want to say, when this tile is clicked, we want to launch the show. But you'll notice here that all of those stubbed out methods that we put on our app view model class earlier actually end up being really helpful when we need to do logic inside our view models, because we can rely on these conceptual things being available without bringing in the platform-specific code that would hurt our ability to use the portable class library. So here you can see that we're saying, and conceptually with Hulu, some shows we don't have the rights to display on certain devices. We can only display them on the web. So here's our check to say, if this show is web only, but we're allowed to launch it in the browser. So in the case of Windows 8, the browser supports Flash, so we can play shows even if they are web only. We can at least launch them in the browser. So here we say, if it's web only and we're allowed to play web only in the browser, then just ask the app view model to launch the show URL in the browser on that platform. If we can't play it in the browser, then we want to ask our app view model to show an OK dialog that says, oh, sorry, we can't play this. And then finally, if it's not web only at all, we want to ask our app view model to navigate to the location or to the page for that show. So all of this is possible because we've stubbed out our implementation details into some reusable concepts that are the same across every platform, and then we build off of those reusable concepts inside our portable class library and view models. It's been a very, very successful pattern for us. So with that, we want to, yes. So I want to go through really quick here. Go through just a quick browse through the application. So again, as I was saying earlier, here's our nav tiles. These are our pages. So this is the television page. You can see up at the top here, there's up over at the top here, there's a title. So that was the property off of the page view model that has a title on it. Here we've got various sections, and in this case, our list of tiles would be however many that is, like 10 big, 10 long here, but it's not infinitely scrollable. However, if we go and expand it, we can get to a page. Now this page with an expanded view is bound to the incremental items where we can infinitely scroll it as you slide through. Let's see here. So again, just very similar concepts throughout the application. Makes it a really nice pattern to use. So great, I think I actually sped through that.
Okay, so if we have any questions of implementation, either what you saw from my side of things in context of the Hue lights, or anything I've talked about, or Zachary in terms of Hulu Plus, we'd love to take those now. Yes?
Sure. So the question was why we have the iHulu collection. One of the things we wanted to do was support the supports incremental loading interface on Windows 8. And so we've got our own sort of collection object that implements that interface and also provides various helper methods on it. So if we want to support a lot of our internal data sources, so at Hulu we have a querying service that supports various types of collections, like give me the popular videos, or give me the featured videos, or give me all the videos for season 1 of this particular show. All of that logic is hooked into our Hulu collection and loader classes. So our Hulu collection basically represents it implements all the standard list interfaces, but it knows how to fetch based on a data source that we provide to it. And then it also knows how to fetch more items for each of those data sources. So when we do encounter that I support incremental loading interface and we do get the call to load more items in this collection, we automatically know that, hey, it's this data source. We've already fetched the first page. Now we need to start at page 2 of our data. So makes for a pretty helpful thing. And then on Windows Phone 8, we use the same Hulu collection, but I think in that scenario, we listen to the item realized event and ask the Hulu collection to load more of itself.
Hey, for Matthias, this is sort of an old topic, but I was wondering how you feel about using dependency objects instead of iNotify property change to implement MVVM.
Well, I'm using the microphone so I don't have to repeat the question. I think dependency properties give you kind of a lot more in terms of what you can do with them. I'm trying to remember all of the different things. It's been a long time since I wrote controls, which is where I usually use my dependency properties. But I think dependency properties still do the updates. If I recall correctly, that you can do things like tell what the old data was going to be and the new data. So I mean, for me, that's really great if you're building an application that's particularly, I don't want to use the word slick because that makes everybody else sound not slick. But if you're transitioning between information 1 and information 2, the dependency property can give you that old data versus new data, so you can make that transition. But I mean, it's fine. I don't know specifically if there's a performance hit on dependency properties, little one. But I especially for like a lightweight application, that would certainly be a good model. So.
Did you guys use any MVVM framework for your design?
In the case of the Hulu applications, we did not. We were available on Windows 8 right at launch, and I believe at the time there we looked at a few of them, but the support there was kind of iffy because there wasn't a lot released about Windows 8 publicly at that time. So we just tended to keep things pretty lightweight and roll our own there. That's not to say that you wouldn't get a lot of benefit using one of the frameworks that are out there.
So for the Hue Lights demo, if you download it, you'll notice there are dependencies on MVVM Lite. And what I've done with that, I think one of the things people don't get about MVVM Lite is it's not an all or nothing proposition. And so in order to make the commanding structure a little bit simpler, because this project is meant to be sort of a tutorial getting you into MVVM sort of thing, I took the relay commands out of MVVM Lite and just used those. So that I had a very simple commanding structure where you just had your command property and it just ran the Lambda function that you needed to run. To me, that was a cleaner way of looking at the code, and so I pulled that from MVVM Lite. When I do my own applications, I do rely on MVVM Lite, but I know a lot of people have had success with Caliburn and Meth and
Explain about your application view model a little bit more, especially the show message and all that.
Yeah, certainly. So we have our application view model instantiated basically in the app.xaml.cs constructor. So right at the beginning of the application, right when our app is entered, we create a new app view model. So there's a subclass per application or per specific one. So Windows Phone 8 will say create a new phone app VM. Windows 8 will say create a new desktop app VM. But then the implementations themselves all rely on logic that's inside each specific project file. So we have a Windows 8 project and a Windows Phone 8 project, and those are the ones that are responsible for saying, okay, I'm going to override the show message function, and I'm going to call all the specific APIs needed for that platform. Does that answer the question for you? Cool. Oh, and one small catch with that, a pattern you'll also see in a lot of this stuff is inversion of control. So I was skimming over a couple details there, but we actually maintain a registry of interface to implementation on both of our platforms. So we can say that we want to register on the phone side that the implementation for app view model is phone app VM. And then whenever we say, get me the app view model for this platform, whether it's in our platform specific project or the portable class library, it'll rely on that registry of interface to implementation to get the correct one. And that gives us a very nice way to indirectly link between APIs and libraries even while using the portable class library, which typically makes it a little bit more challenging to link to external code.
I'm going to skip over this resources section one more time. If you are, if you're interested in the Hue Lights project, which is just a clean MVVM, I wanted something that had services and properties and view models and everything. You go to huemvvm.codeplex.com. If you're interested in MVVM in depth, Laurent Pugnon, who is the author of MVVM Lite, talks about it in an enormous amount of detail in a 4-part MSDN series. It's great if you're looking for more detail on MVVM. And then
yes, one thing to keep an eye out on is the tech.hulu.com blog. We are going to be launching a set of a couple of blog posts there. So the code that you've seen in these slides will be available online, and it's all copy-pastable. You can take a look at there. Obviously, it's a subset of the actual implementation, which would be way too big to go over here. But if you take a look at this blog post, I'm going to be giving a lot more code samples and a lot more in depth on how we implemented this stuff in the near future. Do we have another question?
My question was, what kind of, actually, you mentioned that you use MVVM Lite for some parts?
I do, yeah. Yep.
Yeah, you. Okay, and my actual question is, what kind of IOC patterns do you use, or IOC containers that you use?
So I use the simple IOC. And I use the one that's inside, which I think Laurent's, that's Laurent's simple IOC. And I use that. The inversion of control is, it's a great pattern.
Yeah.
And I think he uses that inside the view model locator. But outside of that, it's just kind of, I don't make extensive use of it. I just kind of follow the pattern that he's put in place.
Okay. But any experience with Ninject, for example?
I have not used Ninject.
Okay.
But I know people who are happy with it.
Next question?
Yeah, I was curious, have you found any good way to do visibility between platforms? Because with the view model being in the PCL, do you use bools and then converters, or?
Yeah, that's actually a great question. So I'll be giving code samples soon on that tech blog post, but what we do is we have just like an IUI interface, and we register an implementation per platform, and that has a bunch of handy helper methods to say construct visibility visible on this platform, construct visibility collapse. It is a shame that we can't just access those directly in the portable class library, but we found the UI framework to be the best sort of work around that. And we do it for all sorts of things, like if we need to create a thickness object, or if we need to create a size object, things like that. Any of that stuff that's not in each platform, and it's just because it's slightly different namespaces, we just stub out and create with helper methods.
Thanks.
Well, great. Do we want to talk about our question?
I have a question, if you don't mind.
Oh,
Okay.
yes.
For the Hulu Plus application, how did you handle tombstoning on Windows Phone? Did you use any open source libraries for them, and to what extent did you go? Did you save the state of your view models, or what the user has input with? How did you decide where to stop?
So one of the things we pushed hard for, our first version of the application did not do this, but current versions of the application do now. We try to make all of our navigation parameters, so you saw that we stub out the navigation logic with a navigation action, And we try to make everything that's inside that navigation action easily serializable. So in the case of Windows Phone 8, we convert that navigation action into a URI string. And in the case of Windows 8, we actually have a parameter object that we can pass that navigation action as. So in doing that, we end up keeping the logic to recreate all of our pages very, very lightweight. So if it does get tombstoned and we come back to it, it's going to launch the same navigation action. And from there, we can pick up exactly where we left off.
Great set of questions. Thank you. Okay, so now we're going to give away this